Hello everyone, my name is Alex. I'm going to start us off by going through the initial configuration and setup of the FortiFi device itself. For context, this is what the device looks like. It's just a small form factor computer running Red Hat Enterprise Linux 9. The physical setup is relatively easy. It's plugging it in. There's two RJ45 ports. You're just going to plug in with two copper cables, one to your home router and then one to the ISP modem or wall or whatever is on the other side of the connection, and then power it on. From there, the device will blast out via MDNS its hostname, which in this case right now is fortify.local. You're going to scan a QR code on the device. It'll automatically redirect you via browser to this page so you can start the setup. The UI is relatively straightforward and simple. In this case, we're just going to hit Start Setup. It's going to prompt you for your Wi-Fi credentials. We're going to type in mine, which are the land before time, and password. I'm going to try to connect. It's going to test that it has internet connection. It's going to connect the Wi-Fi. And then from there, it's going to try to authenticate with our server in the cloud, which in this case it does. It's going to receive a JWT token. This step in the process also triggers a series of services in the background, services, cron jobs, and a couple scripts that configure the device to operate on your network, start the packet capture, start the model running on the device itself, so on and so forth. From here, you're going to proceed to device registration. This is going to redirect you to the cloud where it's going to prompt you to create an account. We're just going to create a test account. Once you create an account, it's going to verify that it can create the account successfully, which in this case it does. And it's going to tell you that you can now log into the mobile app to monitor the network based off the information sent by the device you just set up.
All right. So the first model is detecting what type of IoT devices are present on the network. Data set we used was from Kaggle and covered about 9 category of devices, which are listed here on the left. And this is a classification report detailing the performance of the model for each category. We think the model is doing fairly good across. Focus really is on recall. The only two devices, lights and socket, that we can see is um, performing above the threshold that we placed, which was 90%. Work in progress, it was less in the beginning. We looked at some features that were contributing much to the performance of the model and dropped a few. It went up. So far, this is the highest it's gotten. So definitely be looking closely at those and the performance for security camera and smoke detector. The second model is the model that's detecting the suspicious, excuse me, or malicious behavior from the devices on the network. Initially, the data set covered about 4 types of attack: DDoS, horizontal scanning, command and control, and file download. Command and control and file download were so not well represented in the data set, and the model was not performing well in identifying those cases. So we dropped them from the database for training and went with horizontal scanning, which is represented by label 1, and DDoS by label 2, and 0 represents normal traffic. This model is doing very well across, much more record on this data set for training and testing, and moment of truth is when we're going to deploy it on the Raspberry Pi, which is how we saved it in this step here, and see how it's performing based on the traffic that's coming in. Yes. Now for the LLM, um, we have a few messages set up to give context to the LLM, what we're doing, and how to respond based on the user input. I'll quickly run through here and want to mention that this sample was taken from the test set, and it is associated with DDoS type attack. So prediction is 2, which is DDoS, which is good. And agent is telling us, oh, there's suspicious activity, and the IoT device on your network is exhibiting behavior consistent with DDoS. Give explanation of what it is, and do you want a recommendation on how to resolve it? Yes. And it's giving me top 3. We decided to set it to 3 because initially it would give 10, 8, 11. It wasn't consistent, and we also felt like it was a lot of information to the user, so we brought it down to 3. Identify and isolate the device. Explanation: finding, disconnecting the problematic IoT device. Update, look for any updates, software in your computer, updating it. Implement network monitoring, which is what our solution is doing actually. But yes, giving recommendation based on what was predicted. Um, I'm gonna say, sure, I need extra help. Um, how to isolate device from network and giving me four. And so far, we still need to fine tune for the help function so it makes sure like someone that's not technical, excuse me, will be able to understand. And if I say I don't need extra help, then interaction is ended, conversation is ended.
Hi everyone, Alex again. Now I'm going to talk about how the packet capture works on the FortiFi host itself. So just to give you a brief overview of how it works, there is two Ethernet interfaces on the host itself. They're configured as a bridge that's invisible, so anything plugged into those ports doesn't see that. It just sees the destination on the other end. So for example, if you plug in a modem and a router, and the link is going to seem like it's unbroken even though those two Ethernet interfaces are there. And then we're using a open source tool called Zeek. It's very similar to TCP dump. It just offers a little bit more configurability with custom filters that let you choose what kind of packets and the different fields from those packets you want to capture. I'll show you an example of one of those filters. Uh, as you can see here, we're looking for things like timestamp, ID, source and destination, IP address, source and destination port, protocol, packet size. I'll also show you an example of one of these capture sessions. So these are all about a minute long. We rotate them every minute so we can feed the files to the model one at a time, just like this. As you can see, the different headers I was previously talking about, and then the packets that were captured during that 1 minute session below, just a bunch of different types of traffic. Currently, right now, on the other end of the port, one of the ports of the device is just a Linux host that's running TCP replay on a series of PCAPs from known malicious IoT traffic. It's about 20 gigabytes of data, so the device just filters through the PCAPs one at a time and injects that traffic into the interface, so the Zeek capture can ingest it and then create these connections and send them to the model. So I'll also show you an example of the predictions that are spit out after the model is run. So it's just a Python script that's running the model locally on the host and ingests these files one at a time, and then it spits out a prediction for each packet. The predictions are very simple. Right now it's just in a JSON format. As you can see right here. So right now we have 7,700 zeros, 1,222 ones, and 02s. So the numbers represent different types of traffic. One is benign, zero is benign, one is port scan, and two is DDoS. As you can see right now, we don't have any DDoS packet captures running during the session, so there's no twos, but there are several port scan packet captures running, which would cause the 1,222. What happens is when the model predicts a 1 or a 2, it generates an event, and that event is wrapped up in a post request to the server that Jonathan will talk about in a little bit.
So once users set up the hardware device and create an account through the QR code that's presented on the device, this account will be linked to the Raspberry Pi, which allows notifications and updates to be sent. They can log in to the mobile application, as we see here, and they're met with this dashboard, which gives them network insights based on the status, how many threats are found, and then a distribution throughout the week. So right now we see there's no events found, there's no threats found, and the distribution's pretty much empty. Which brings us to the first role of the hardware device, which is to notify intrusions. Using the model that's loaded on the board, whenever it detects harmful traffic, it should hit this notify intrusion endpoint. We'll see two examples, one for DDoS and one for port scan, which updates the corresponding account. So now we see the dashboard updated. If we navigate to needs attention, we see the two threats with more details that can be provided: source IP, destination IP, time, the type of the attack, as well as details. Ideally, they can use the Ask AI for Assistance button to navigate to the chatbot, which isn't implemented in the iOS client, but we've seen the functionality of it before. Now, you might notice the distribution traffic and the event insights down here haven't been updated. That's because the next role of the hardware device is to run a cron job that updates the distribution of traffic at the top of every minute. So if it sees traffic that it identifies as a port scan, it'll update the counter. If it sees traffic as DDoS, it'll update the counter. And for, variety, we'll say this is 3. And benign, which is correlating to normal traffic, is probably going to be a lot higher. So we'll set this to something like 43. So if we update the weekly distribution, we'll see these charts updated down here. And at the end of every week, the Pi is also supposed to reset the weekly distribution just to give users input on the change in network. So we'll see an example here. If we reset the weekly distribution and reload the page, we see that the events this week are down 298 from the previous week, which might be useful for people worried about the status of the network and if there's any abrupt changes in the traffic. Next, we'll see the devices page. Right now, there's no tracked devices, but using the IoT detection model, whenever a device is tracked and identified as an IoT device, the endpoint should update the user's account accordingly. So our tokens have expired, so we're going to refresh using a refresh token and add a bunch of devices so you can see that displayed on the UI here. We'll have to reload here. Going into the details, we see the date added, IP address, and MAC address, as well as severity, which is correlating to the incidents that this device has been associated with. In the future, we might consider adding an option to remove the device from tracking. We're not sure what the purpose of that would be. It just seems more secure to have it tracked once it is determined to be an IoT device. But maybe for privacy reasons, it might be good to add that capability.
Revisiting our use case for the product, network recovery and remediation, we can see how users might be able to navigate to the flagged events, view the details, and prompt the chatbot for assistance on how to respond to this attack, what steps can be taken to prevent further escalation, and maybe what the root cause of the attack was. And being able to track the devices and the incidents that they have been involved in, as we see, like the severity, this is also useful in securing the network in the future. Maybe it looks like removing the device from your network or resetting it.
Hey everybody, Christopher Black here. I thought I would take a couple of moments to walk the class through where we're at in terms of our CI/CD capabilities. I'm just getting over a terrible cold. If it sounds like I'm sick, I sound a lot worse than I am. I've been working in the shadows for the past couple of days. What we see here is a visualization of our pipeline on the Harness platform. And in full transparency, I work for Harness. I think it's an amazing platform. They have an amazing free tier. So if those of you in the class are thinking about CI/CD for any of your projects, I recommend giving Harness a try. Our pipeline is comprised of stages. Stages are comprised of individual steps. And so that's what we see over here. So the past couple of weeks, I've been working on configuring our CI/CD pipeline to interface with GitHub, right? That's where we store our source code. So the first thing I had to configure was something called a connector, right? Enabling the Harness platform to git clone all of the source code, all of the source materials associated with our project. I'm going to click run up here, and I'm going to specify which branch I want to run a pipeline on. Okay, this is going to run our pipeline. It's going to pull out, it's going to check out our code. I've also stood up a MySQL instance as a sidecar container. I think I mentioned this in class previously. This is actually a really handy feature. We have a live running Postgres SQL instance available on a local shared network, right? It's available via localhost. So as we run our tests, we're actually able to interface with a database as part of our testing process. It's really, really powerful. It's a great idiom. You'll also notice the step up here, inject Firebase secret. So we do have a couple of API keys we have to manage. Typically in CI and CD environments, you have to leverage either a third-party KMS technology to reference your secrets. Harness thankfully has pretty powerful native secrets management. And so we're storing a lot of our cryptographic information, API keys. We've got a JSON-based auth file. We're storing all of these as base 64 encoded secrets on the Harness platform. Right now, we're running our pipeline manually. The next thing I plan on doing, either next week or very soon, is we want to configure this to run on every PR, right? When you think about why organizations practice CI, it's to amplify that developer feedback loop. So that's the next iteration of this process or project, or both, is to run a pipeline on every PR. And then we're going to have a nice PR-based integration on GitHub so we can get our pipeline results, we can get our test results directly in the PR itself, again, amplifying that developer feedback loop. And that way, if we catch any errors, we catch them early and often, right? That's a big part of the philosophy with CI/CD. That is certainly all I've got. I think I'm going to pass it off to Lawrence to take us home.